Hello everyone, welcome to One Stop Mathematical Solutions. Today we are going to solve a linear algebra questions from GATE exam. The question is, we are given a set of vectors and we need to find the set of x in R for which these vectors are linearly independent. So the concept we need is, under what condition we say a set is linearly independent. A set of all vectors is said to be linearly independent if the determinant of the vectors is not equal to 0. So let us find the determinant. So I'm writing the vectors like this: 1, x, 0, the first vector. The second vector 0, x square 1. The third vector 0, 1, x. And the determinant 1 into x cube minus 1. And other two things are 0, so x cube minus 1. So we need to find the condition for which this determinant is not 0. That is, this value x cube minus 1 is not 0, which implies x cube is not equal to 1. This implies x not equal to 1. So the answer is the set of all x for which x is not equal to 1. The next question is, we are given two maps f and g from R3 to R3 and we need to find which one is linear and whether both are linear or both are non-linear. The concept of linearity is, if we are given a function f, then we need to check whether f of x1 plus x2 equal to f of x1 plus f of x2, and f of ax, where ax is any scalar, then this is equal to a into f of x. So for the first function we are given f of x y is set equal to x mod y is set. Let us check whether f of x1 plus x2 comma y1 plus y2 comma z1 plus z2 equal to f of x1 y1 z1 plus f of x2 y2 z2. This is what we have to check. So the left side gives f of this value is nothing but this one, no? So the first is x kept as itself, so x1 plus x2. The second term mod y, so we need to write mod y1 plus y2. The third term is kept as z itself, so z1 plus z2. So this is the left hand side. So let us check what comes in the right hand side. Right hand side, first we will write f of x1 y1 z1, that is nothing but x1 mod y1 z1 plus f of x2 y2 z2, that is x2 mod y2 z2, and adding these vectors we will get x1 plus x2 comma mod y1 plus mod y2 comma z1 plus z2. But notice that these two are not equal. The first term is equal, the third term is equal, but what about the second term? The second term, we know the inequality, which is called a triangle inequality. We say mod y1 plus y2 is less than or equal to mod y plus mod y2. So these two are not always equal. So the first condition, no, that f of x1 plus x2 equal to f of x1 plus x2, this condition itself fails, so f is not linear. Now the function g of xy z equal to x plus 1 y minus 1 z. Now let us check g of x1 plus x2 comma y1 plus y2 comma z1 plus z2 equal to g of x1 y1 z1 plus g of x2 y2 z2. This is to be checked. So let me take the left hand side. which gives, start with the left hand side. See, in the given function, the x term is mapped to x plus 1. So I will write here as x1 plus x2 plus 1. And the next term y is mapped to y minus 1. So here our y1 plus y2 is mapped to y1 plus y2 minus 1. And the third term is kept as it is. So I will write z1 plus z2. So this is my left hand side. So let us check the right hand side. First I will write g of x1 y1 z1, which is x1 plus 1 y1 minus 1 z1, plus g of x2 y2 z2, that is x2 plus 1 y2 minus 1 z2. Adding these vectors together, we'll get x1 plus 1 plus x2 plus 1, which gives x1 plus x2 plus 2, and y1 minus 1 plus y2 minus 1, which gives y1 plus y2 minus 2, and the third term is z1 plus z2. And clearly these two are not equal because the third term is the only thing that is equal. The first thing is different, second is also different. So g is not a linear function. See, we have checked only one condition here, no, for linearity. The second condition you can check, it will come true. But that doesn't matter. Even if one condition fails, the function is not linear. So here neither f nor g is linear. The next question from linear algebra, we have a matrix M. We need to check whether M is diagonalizable or not, and whether M square is diagonalizable or not. Here we need to use only a simple concept, that is, if the eigenvalues of a matrix is distinct, eigenvalues are distinct, then the matrix is diagonalizable. Okay, so let us start with eigenvalues. How do you find the eigenvalues of this matrix? There is a short way, because it is a very simple matrix. So, yeah, upper triangular matrix. Eigenvalues of the upper triangular matrix are the diagonal entries. Not only upper triangular, also for lower triangular, also for diagonal matrix. The eigenvalues are the diagonal entries. So for this matrix, eigenvalues of M are 1, 4 and 9. Since all the eigenvalues are distinct, we have M is diagonalizable. And we need to check for M square. If lambda is an eigenvalue of M, this implies lambda square is an eigenvalue of M square. So what are the eigenvalues of M square? One square, 4 square, 9 square. Those are 1, 16, 81. So these are also distinct. So M square is also diagonalizable. So the answer is both M and M square are diagonalizable. Thank you.